This recording is actually the first video out of three very short videos that I'm going to create for lesson 3.3. And in lesson 3.3, we're talking about determining the probability, the chance that something will happen, trying to determine that probability experimentally. Sometimes we run into situations, and it happens often, where we don't know how to calculate the probability of an event. And so because of this lack of knowledge of how to determine that probability, we try to create a little experiment, a simulation that represents that scenario, and then we run that simulation or do that experiment many times and check the results and determine our probability that way. So in order to get started here, there is one kind of mathematical prerequisite skill, a pre-requirement skill that we need to be able to work through the problems in this lesson. So I want to take a look at that real quick. So my question to you right now, think about this. How many integers, you could think of it as whole numbers because we're positive values here, how many integers are in this closed interval from 1 to 30? How many counting numbers are in that interval? Think about it. I mean, I hope right now you're thinking that there are 30 numbers in that interval. I mean, we could list them, I suppose, 1, 2, 3, and so on, all the way up to 30. But there are 30 integers in that interval. Now, what about this interval? How many integers now? I'll bet if I could hear all of you thinking right now, some of you are saying 3, and some of you are saying 4. So maybe what we should do is list them. This is a small interval, 5, 6, 7, 8. There are 4 integers in that interval. How about this one? Well, I hope now you're catching on. There are 5, right? 10, 11, 12, 13, and 14. Now, can we come up with a system, a plan, a way to do this without having to list these all of the time? What about this one? That's a bigger interval. I'm not going to list them all. So we need a method, we need a pattern, a way of figuring out how many integers are in the interval. You see it already, don't you? It involves subtraction. So what we really need to do here is we need to subtract. And what I mean by subtract, we have to subtract. We got to go the biggest number minus the smallest one, right? But if we subtract, for example, up here, 30 minus 1, that's 29, and we're actually going to be 1 off, right? So what we really need to do is subtract and add 1. I'll bet a bunch of you knew that already, right? So if we subtract maximum minus minimum and then add 1, we'll know how many numbers are in the interval. So here I can go 53 minus 32, which is 21. Then I have to add 1. So there are 20, should go back to red again, but there's 22 numbers in that interval. So this is the key kind of mathematical idea that's involved in the simulation problems. And I'll point that out to you now in the one example that's included in this video. So simulations are a very important part of the statistical world. Simulations or math models, or sometimes called computer models, are all really the same name for the same, or different names for the same concept, where we create a model and then try to use it to determine probabilities. And we've seen that in um, this COVID-19 situation that we're in right now, and we're relying on these mathematical models or these simulations all of the time to determine the kind of behavior, how we have to modify our behavior in the upcoming weeks yet to try to slow the number of cases of COVID-19 that occur. Well, in each of the simulations you do, and I'm just going to show one example here, but there's really four. I'm going to uncover all four right here. There's really four things that you need to be able to do. Firstly, number one, you need to be able to use your calculator or your Chromebook or your phone to generate a random number. And on our calculators, there's a RAND function. RAND stands for random integer, and your calculator can generate a random integer. We'll talk about it in a moment. Secondly, you need to be able to explain in each problem what the generated numbers mean. For example, if your calculator gives you an 8, what does an 8 mean? Does that mean 8 people were involved? Does that mean the average age was 8? You know, what does it mean? And then generate data by generating random numbers. And then finally, after you generate the data, you've got to describe what that means. So you're going to describe how you're going to generate random numbers on your calculator, and then you're going to declare what each number means. Then you're going to generate the numbers, and then explain what those numbers mean. So there's a 4-step process, and I'm going to conclude this video then with just one example. Here's my example. A huge bowl a glass bowl has a whole bunch of candies in it. 50% of them are mints, 40% are butterscotch, and 10% are cinnamon candies. Simulate the random selection of a piece of candy and knowing what type it is. Do this 20 times and keep track of what percent of your choices were of each type of candy. Okay, so we have to think about this now. We have to generate a random number. So we got to decide how are we gonna do that? Well, you can download random number generators on your phone. You can do a Google search and just type random number generator. You could also go, I do know on your Chromebooks, if you go to random.org, there's a random number generator right on the cover page of that website, so you can go to random.org. But for those of you that have the Texas Instruments scientific calculator, when you hit your PRB key, like we have been the probability key for counting with permutations and combinations, if you hit PRB and use your right arrow key, keep hitting your right arrow key, and you'll see RAND and you'll see RAND int. So if you hit PRB, keep sliding to the right until you underline RAND E. Let me make some room over here until you underline the RAND E function. And it looks like this, RAND with an I. And then if you select that, it's going to show you a left parenthesis. And what you need to do is enter the smallest and greatest possible value that you want the calculator to generate. So, for example, if you want to simulate rolling a six-sided die, you would type 1, 6. That's telling the calculator then that you want to generate any numbers from 1 to 6. And if you then hit equal on your calculator, it's going to roll the die. And if you hit equal again, it's going to roll it again. And if you just keep going equal, 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 it's just going to keep rolling the die. So that's how you generate a random number on your calculator. Most of you hit the PRB and then choose Randy for random energy. Okay, let's get back to our candy problem. So in the candy problem, I'm going to demonstrate how I want you to demonstrate for me the answers to your exercises. So what I've decided to do here, going back and reading the original problem, 50% of the candies are mints, 40% butterscotch, 10% cinnamon. So what I decided to do, and you can see it right here, here's my step 1. I'm going to generate random numbers from 1 to 10. 1 to 10. And now step 2, I'm going to declare what each of those numbers mean. So whenever my calculator gives me a number, and you can see it right here in the lower left, whenever my calculator gives me a number 1, 2, 3, 4, or 5, that's going to represent the selection of a mint candy. And whenever my calculator gives me 6 through 9, that's going to be butterscotch. And remember what we just talked about prior. 9 minus 6 is 3. 3 plus 1 is 4. There's really 4 numbers in that interval representing the 40% butterscotch. And then down here, finally, the number 10, if it's generated, that's going to represent this selection of cinnamon candy. So I've typed into my calculator how to generate the random number. Secondly, I've declared what each number means. Then the third step of our process was to generate data. And here's my data. I've done it already. I set my calculator on 1 to 10, and based on the directions of the problem, 20 times, I generated 20 numbers. It's just like taking 20 different pieces of candy out of the bowl. Now, I've gone back and I've started analyzing my data. Any number that represented a mint candy, remember mint? Look over here. Mint was any number from 1 to 5. Well, I've gone through and I turned those yellow. Any number from 1 to 5. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times I got a mint. Now I'm going to count the butterscotch. Well, actually, I counted the cinnamon ones. Look down here. Cinnamons were number 10. I got 2 of those, right? I got 2 cinnamons. And I don't even really have to count the other ones, but I guess I will. But these better add up to 20, right? I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 of those as well. So let's see, that adds up to 20, right? So that's a good thing. I'm going to try to move my recording thing over here. Okay, so it adds up to 20. That's good. So now I'm going to calculate my percentages because 50% of the candies were mint and 40% were butterscotch, 10% cinnamon. I'm going to see what percent I got when I selected. So now I'm going to calculate my percent for mints. So I would do, let's see, I got 9 out of 20. I'm going to divide 9 by 20, 0.45. That's 45%. Well, this 9 for butterscotch is going to be 45% too, right? 9 out of 20. 45%. And then finally, 2 out of 20 2 out of 20 is 0.10. That's 10%. And so my simulation shows that I got 45% of the time I got a mint, 45% butterscotch, 10% cinnamon. Now, that's not too far off from the actual percentages of candy that are in the bowl, right? It's pretty close. And the law of large numbers, remember that one? The law of large numbers would say, if I kept selecting, if I would have repeated this more than 20 times, maybe I'd do it 50 times. Then I'll bet these percentages are going to start getting even closer to 50, 40, and 10. That's the law of large numbers. Revisit it again. Okay, so in this one example, you see the 4 really important steps in your simulation problems. Write the Randy statement, generate the numbers, write the Randy statement, then declare what the numbers mean, then generate the numbers, and then interpret the meaning. So again, I've done that here. Firstly, here's my Randy statement. Secondly, declared what the numbers represent. I generated my data, and then I interpreted what those numbers mean within the setting of the candy bowl question. So that's the end of this video, just showing you the importance of how to display your data when you work through these problems. There'll be 2 videos to follow.